In the previous nugget, we enabled IPv6 and configured it statically on DCNug on server 2, and we also verified that our client could do SLAC, the stateless address auto configuration, because we had trained server 2 to issue router advertisements that contained the prefix or the network 2001 DB86783 with the 64-bit mask. And as I was setting up and getting ready for this nugget on implementing the scopes, I noticed a few interesting things, and I wanted to share those details with you because I think you'll benefit from it as well. The first item I noticed was that I was on this client Nug, and I was doing a remote shell up to server 2, and it wasn't working consistently. I do a Control-Shift-R, and sometimes it would work, and sometimes it wouldn't work. I was like, what the heck? And what I discovered was that DCNug has two DNS entries for server 2. It's got 192.168.1.102 and also 10.0.0.102. And that information is being fed back to my client. And if my client chose to use the 192 address space for the server 2, no problem. However, on the occasion that my client would choose to use the 10.0.0.102 address, this client doesn't have a route to get to the 10 network. And as a result, it was trying to send to the default gateway. And anytime that a computer has an opportunity based on a random chance to do something wrong, especially if it's in a network, we want to avoid that. So as part of housekeeping, I'd like to add a static route on this client that says, hey, dear Mr. Client-Nug, if you ever need to get to the 10.0.0 IPv4 network, go ahead and use the next hop of 192.168.1.102. Because server 2 is configured as a router for IPv4, and that way, regardless of which interface you try to connect to, it'll work consistently. And that's what we want. We want consistency in our networks. So let's jump over on Client-Nug right now and take care of that. So here on Client-Nug, if you're following along in the lab environment, here's what I'd like you to do. I'd like you to right-click on the PowerShell scripting environment, and then from the menu, it says Windows PowerShell. Don't just open it up normally. I want you to right-click on it. And then from that submenu, I'd like you to go ahead and run that as administrator. And it's going to ask for a confirmation message, and we're going to say yes to that. Because to add a static route, we're going to need administrative privileges to do it. So go ahead and launch the PowerShell scripting environment with the administrator privileges. So here in the local tab for the local machine and with administrator rights, let's go ahead and launch NSLookup just to see what DNS serves back to us regarding the IP address or addresses for server 2. So at the NSLookup command resolving server 2, let's go ahead and press F8 to go ahead and execute that. And sure enough, it's giving us back both of them, and hopefully our client would be smart enough to go to the one that's on the local subnet. So it's in the off chance that our computer tries to connect to the 10.0.0.102, which is going to cause us grief. So if we want to see our routing table, we can do a get-netroute space dash address family space IPv4 for the IPv4 routing table. And if we execute that command, here's our IPv4 routing table. And you'll notice we are directly connected to the 192 network. That's why we have some entries there. There's some multicast information, some broadcast information, and some loopbacks. And then this bottom route, 0000, is the Obi-Wan Kenobi route. Help me, Obi-Wan, you're our only hope. And that's using the next hop of the default gateway. So it's not in the local routing table. We're forwarding packets to the default gateway, to the default gateway's layer 2 address more specifically, so it can make a forwarding decision. And in the case of the 10 network, that's not going to help us because that router at that IP address has no idea about our internal 10 network. So another way of looking at the routing table is route print. So if we execute route print, and that gives us IPv6 and IPv4 information. Also with the get-netroute command, we could use address family IPv6 to see the IPv6 routing table. So let's create a new static route on this Windows 10 client to tell it how to get to the 10 network. Now previously in this course, we did the route add command, and that was on DC-nug to tell it how to get to the 10 network. We could also use a PowerShell command for the same result, and that command is new-netroute-destination prefix. Here's the IPv4 network we're trying to reach. Here's the next hop of 192.168.1.102. And our egress interface that we should associate this route with is Ethernet 1 on the local machine. Egress is a fancy way of saying the outbound interface that we're going to use to forward a packet to get to that network via this next hop. So with the new-netroute command highlighted, let's press F8 and execute that. And what it did for us, it put it in the active routing table, and it's also persistent, which means that if we reboot this computer, it's like the -P option with the route add command. If we reboot this computer, that static route will still be there and be loaded into the routing table the next time the computer reboots. So if we go back and did a get-net route for address family IPv4 again, just to verify and execute that. Now we have our static route right here of 10.0.0 using the next hop at 192.168.1.102. And so now if we ping 10.0.0.102, that should work. And it does. Fantastic. If we ever open a connection from the client over to server 2, regardless of which IP address our client tries to use, learned via DNS, it can now be successful because we have routes to both of those interfaces. Okay, great. Now the next problem that I'd like to go ahead and walk us through the solution for is why in the world do we not have an IPv6 address on the 2001 : etc. IPv6 network? Because when we left our last nugget, we had one. So if we run ipconfig/all again, it should be in this area right here. It's not there. So let's take a look at what should be happening based on our previous nugget and its configuration of this network. Server 2 should be sending router advertisements into the network. It should have the prefix of 2001 DB86783 with the A flag, the autonomous flag, set to on, which would then indicate to the client to use that network address and run Slack. So after some analysis and looking at this behind the scenes, let me share with you what I found, and then we'll fix it together. Here in our Windows 10 client, let's go ahead and do a Control-Shift-R and open up a PowerShell session over to Server 2, which is srv2-nug, and press Enter to open up that remote tab. So we'll go ahead and click on View, and we'll click on Show Script Pane. And also, let's open up the script document that we used in our last nugget. So to do that, let's go ahead and click on the File folder for Open. We'll click on Temp on the left-hand side here. And here, we'll click on the 36-IPv6 for Server 2-nug. And these are the scripts we used in our previous nugget for the configuration. So let me go ahead and do a CD / to give us a little more real estate here and a clear screen. And here's what we did. We did a set net route for an existing route that was in the routing table, and we added the option of -publish yes, meaning advertise this route. And that's why it got advertised in the routing advertisements for IPv6. So let's take a look at the IPv6 routing table on Server 2 that we're connected to via this tab. So get-netroute -address family IPv6 and press Enter. So here it knows about that route because it's in the routing table. And so in our last nugget, what we did was we modified the existing active route and we told it to go ahead and do the publish, which caused it to show up in the router advertisements. However, when we reboot, there's no automatic set-netroute command that's being run every time to go ahead and add the option of publish. And that's why when we rebooted this lab, even though we did the configuration last time, it didn't stick. So how exactly do we fix that to make it persistent? And that, my friend, is what I'd like to walk you through right now. We need to remove that route and then put it back in. And when we put it back in, by default, that configured route will be put in the active store. It'll also be put in the persistent store, which means that when we reboot this system, that route will come back in because it's persistent along with the publish option that makes it advertised in the RA every time we reboot this system. So we're going to have to do a little bit of surgery. So I'm going to remove the existing route. And we'll do that with a remove netroute command, space, and I'm going to do some copying and pasting here. So that's the route we want to remove. I'll do a Control-C to copy that and a Control-V to paste it. And let's hit F8 to execute that. It's asking us, are you sure? And I'm going to say yes. Let's go ahead and get rid of it. And then we'll go ahead and recreate it, and we'll use the -publish option when we create it. And by default, that would be in the active store and the persistent store, with that -publish option being set to yes. So we'll do new -netroute, and then I'm just going to copy all of this right here from the old setroute command and do a Control-C and then a Control-V. So the syntax is going to be new -netroute -destination prefix. There's the prefix we want included in our routing table. Interface Ethernet 0 as the egress interface we'd ever use if we wanted to reach that network. And the -publish yes will include that in the router advertisements. And in addition to that prefix being in the router advertisements, there will also be a bit set for the autonomous flag, which will let clients then know, okay, I should use this prefix while I'm doing my stateless address auto configuration, and I'll build the rest of my IP address based on this network space. So with row 8 highlighted, we'll go ahead and press F8 to execute that. The reason it's showing up twice is because it put it in the active store. It also put it in the persistent store. And as a result, if we go to our client and we do an ipconfig all now, and press F8 on the local client and scroll up. Once our client saw that advertisement from the router and that it had a prefix and had the A bit set, it went ahead and configured not only one, but a couple IPv6 globally routable addresses based on that prefix, including a temporary IPv6 address, which we've talked about that it uses for privacy and security. So now that we have routing advertisements that are correctly being sent again from server 2, and we've also done some housekeeping with basic IPv4 connectivity from client 1 up to the 10 network, let's go ahead and create a DHCP scope for IPv6. So here on Client NUG, let's click on our Server Manager icon in the taskbar and give that a moment to load. Next, we'll click on DHCP on the left-hand side, and then we'll right-click on DC NUG, and from the drop-down select DHCP Manager. And here in DHCP Manager, if we expand DC NUG, expand IPv4, there's all the beautiful work we did with IPv4. We'll collapse that back, and we're going to focus on IPv6. So to create a new scope, we'd right-click on IPv6, and then from the drop-down select New Scope, and simply follow the bouncing ball, specifying the network address space that we want to create the new scope for. So we'll click on Next to continue. We'll give it a name. We'll call it our IPv6 scope. Click on Next. It's asking for the prefix that we want to support. So we'll put that in with a double colon at the end. For preference, if we had multiple servers offering IP addresses for IPv6 for this network, a client could take a look at the preference values and then choose the highest preference. And preference here, the bigger number is more preferred. And since this DHCP server and this scope has no competition, it's still going to win. So we'll go ahead and click on Next to continue. Next, it's asking for exclusions. So if we want to exclude any IP addresses, we could do it here. 100 is assigned to DC NUG, 102 is assigned to server 2, or if we just want to do a specific address, we can just put the first value in there, click on Add, and then put the second value in there of 102, and click on Add to do our exclusions. Fantastic. And then we'll click on Next to continue. Next, it's asking about some preferred and valid lifetimes. So if this is a timeline going left to right, and we'll say the preferred lifetime is right here, marked in blue, and the valid lifetime is 12, marked in green. It would go something like this. The client gets an IP address, starts using it, and it's considered preferred until it gets to 8 days based on this lifetime. Then after 8 days, it's referred to as deprecated. It'll still work, but the client is not going to intentionally want to use that a lot because it's getting closer to the very end of that lease. So after the 8 days, until it gets to the 12 days, the address is considered deprecated, and at the end of the valid lifetime, which is right here in green, it would no longer be able to be used by that client. Not legally anyway, unless you have it like a rogue client. I don't care what you say, I'm going to use it anyway. But computers don't often have attitudes, at least not like that. So the defaults are 8 and 12 days, and if we want to accept those, that's fine. Click on Next. Then it asks us how we want to activate the scope. We click on Finish, and poof, we now have a new scope right there. If we want to configure options for that scope, there's a section for options right here. We right-click on Scope Options, and from the menu select Configure Options. We can configure options, for example, such as a DNS recursive name server for IPv6, and we could add that. So if we put in the IPv6 address for DC-NUG, which is also acting as a DNS server, and click on Add, it did a quick check, verifying that it is a real DNS server that the service is running, and then it added it. So if we clicked on OK, we now have an option. And that option is the name server. And options, very much like in IPv4, work similar in IPv6. If we have a scope option, that option is inherited or received by devices in that scope. And each different scope can have different options. Makes sense. Or if you have options that you want everybody to use, for example, if you had 2 or 3 different IPv6 scopes, if we configure a server option, that server option gets inherited by all those IPv6 scopes that might be present on this server, which is the same concept of inheritance as we learned about with IPv4 server options versus IPv4 scope options. Or if we wanted to create a scope with PowerShell, we could do that as well. In PowerShell, let's open up a remote tab with Control-Shift-R and connect over to DC-NUG. And we'll do a CD / and a CLS to get a little more real estate. We'll do a view and show scripting pane. And if we wanted to add a DHCP server v6 scope here, the command would be add -DHCP server v6 scope space. Then we'd specify -name and give it a name and specify the prefix that we want it to support. A prefix is a fancy word for saying a network space or a network address. So let's use another address like 3000 : beef : That would do it right there. Let's hit F8 to to execute that. And then if we go back to our DHCP manager and we click on IPv6 and then we refresh that, there's our second scope right there. So we have one scope for the local 2001 DB8 network that we're directly connected to, and one for a 3000 network, which if we weren't connected to, we could still receive requests if we had a DHCP v6 relay on that remote network who was listening and forwarding them down to this DHCP server. And as a final quick verification, let's go ahead to our scope 2001 and let's take a look at address leases, do a refresh. At the moment, there are no leases. However, we could trigger one by going back to the client, and we're sitting at the Windows 10 client at the moment. We'll right click in the Windows icon in the bottom left hand corner. We'll go to Network Connections from the menu. And then from here, we'll right click. We'll just disable it just for a moment, and then we'll right click and re-enable it. Now, in the router advertisements, if we force the M flag to be a 1, meaning managed configuration, the Windows client who's paying attention to that flag in the router advertisement would say, oh, okay, I know what I need to do. I need to go out and contact a DHCP server. However, the default behavior is what you're about to notice, and that is even without setting the M bit on, this client is still making a DHCP request regarding an IP address, and assuming a DHCP server responds, which it will now because we just configured it, it'll hand out a lease to this client, and that client will use that lease. So if we go back to DHCP Manager, go to Address Leases, and then click on Refresh, and there it is. So there's the client IPv6 address that our client is currently using, and that's client-nug.nuggetlab.com. And because our DNS server is dynamically getting updates, when clients get new IP addresses, check this out. If we go back to our PowerShell, and we go back to the first tab, to the local computer, if we were to do an NS lookup for client-nug.nuggetlab.com, and with the cursor at the end of that row, press F8, check this out. In DNS, we got the entries for both of its IPv6 routable addresses, as well as its IPv4 address of 192.168.1.150. Which means that if we went to, for example, DC-nug, and from here did a ping -6 to client nug, and pressed enter to execute that, thanks to DNS, it resolved the name client-nug.nuggetlab.com to the appropriate IPv6 address, and then completed the ping. And now, my friend, it is your turn. Take some time in the hands-on lab and practice doing those things that we've done together in this nugget. And that will not only reinforce the learning that's happening in these nuggets for you, but it will also increase your skills in working with PowerShell and working with networks, as well as troubleshooting. So have some fun in the lab, and I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.